Hi, everyone. Welcome to the deep dive session on Amazon FSx for Lustre. To kick things off, I want to share one of the big things, or three of the big things that we hear from customers about the differences between running their workloads on AWS versus running on premises. The first thing we hear is that customers love the ability to spin up virtually unlimited compute capacity to run their workloads in parallel and get results faster. The second thing we hear is they love the fact that they can actually procure that compute capacity in seconds instead of in months, and that they don't have to make big capital expenditure commitments for years to come when they want to run an experiment. The third, and I think most interesting thing we hear from customers about running on AWS is the way that the cloud changes their organizations, the way that it makes researchers more willing to experiment, to try running new algorithms without feeling like they're competing for resources with their peers, without having to make that kind of big capital expenditure because their idea maybe isn't quite fully baked. And so these three things are really exciting reasons that we wanted to basically highlight today and talk about how we make this possible for our customers and really what that means for IT organizations. Because when you can experiment more, when you can create new ideas and innovate faster, you can turn your IT organization from a cost center into a value center. But scalable compute also requires scalable data access. And that can be a big challenge. And if you scale up your compute resources and you don't have the data access to go along with it, you have that storage bottleneck that leads to wasted compute resources and eventually wasted spend. So to address this, the Amazon FSx team decided to take a stab at creating scalable performance for compute workloads. Now, Amazon FSx is a cloud service that we have at AWS that allows customers to easily launch, run, and scale a range of the most popular file systems in the world. Today, we have 4 file system options. We have FSx for Windows File Server, FSx for NetApp ONTAP. As of yesterday, FSx for OpenZFS. And what we're here to talk about today, Amazon FSx for Lustre. The first 3 services are scale-up file systems. They each offer a unique set of features that allow customers to easily migrate workloads to the cloud by having the same kinds of features they depend on for their workflows on premises. And all of these file systems are built using the latest and greatest AWS technologies. What makes FSx for Lustre unique is it's the scale-out file system in the portfolio. So not only is it providing a lot of the capabilities of Lustre, but it allows you to actually meet that data scaling or data access that I just described. We use Amazon FSx for Lustre for a range of applications. And we see customers in financial services, in oil and gas. We see them in video rendering for media and entertainment workloads. So this need to scale up compute capacity crosses a wide range of industries. And it's really being fueled by high-performance computing and machine learning trends. The growing use of both of those application areas on AWS across all of these industry verticals is really driving FSx for Lustre and elastic compute in the cloud. So let's talk about what Amazon FSx for Lustre really brings to your workloads. The first is highly scalable throughput capacity. The second is storage options that are optimized for price performance. And the third is access to Amazon S3 data through a fast file interface. And in today's session, we're going to walk through each of these. We'll start with highly scalable throughput capacity. So with a few clicks in your console or with a single API call, you can create a file system on AWS with a terabyte per second of throughput capacity, millions of IOPS. When you're done with it, you can tear it down. It's pretty incredible from a performance perspective to be able to have that flexibility in your toolkit. And what we see, if you look at what we're launching on the compute side, is EC2 instances with higher and higher levels of throughput, because we have more powerful compute, CPUs, and GPUs that are more data hungry than ever. And it's really important to keep all of these instances fed with data to run your workloads as efficiently as possible. This is why we see such a growing need for high-performance storage on AWS. A typical scale-up file system, like the ones I described below or earlier, take a file from a client instance. You can write it to your file server, write it to disk, and then you can read it back to your client instance. And that's the architecture. It's very basic, very simple, and it works quite well. What Lustre does differently is we build our file systems off a series of servers, each with their own disks. When you load data onto FSx for Lustre, data is automatically distributed across all of the servers, all of the disks. And this is how we achieve that scalable performance. We're getting all of the throughput, all of the network bandwidth of each of those servers aggregated together for your workload. When you read data back, you're getting the full power of all of those servers as well. If you've got large files, Lustre can automatically shard or stripe that data and then send it across to all of these different servers. So once again, you're getting the full performance, not just on a file basis, but on a file extent basis, on a piece of a file, when you write, and similarly when you read. This is basically at the core of how FSx for Lustre delivers scalable performance. And that performance is throughput, it's IOPS, it's the RAM that you have available for even faster reads. And from there, you can get that scalable performance that we talked about before for data access. The Water Institute of the Gulf needed to run a number of simulations to understand what the Louisiana coastline was going to look like in 50 years. When they looked at how long it would take for them to run the simulations on premises, they estimated that it might take around 3 months. By scaling up all of their compute on AWS and using FSx for Lustre for scalable data access, they were able to crunch that down to around 3.5 days. Still the same amount of compute, still the same amount of storage, but now they're able to compress the timeline. Very simple story, but that's the value of the cloud. The second thing I wanted to talk about was storage options optimized for price performance. One interesting thing to note about my customers, FSx for Lustre users, is that around 90% of them don't know anything about Lustre, and they don't have to, because we fully manage the service, and we provide a range of different options for them that we build, we configure, and we manage on their behalf. So from their perspective, it's just a mount point that works really well. You can see here we have a number of different options for storage. We have hard disk-based storage. We have HDD-based storage with SSD cache. So 20% of the file system storage is allocated in SSD cache as well. We have all flash file system options. And then for extreme price performance, we have unreplicated SSD options as well. And so we allow customers to build file systems with a single API call using any of these technologies. For metadata, which consumes around 70% of typical file operations, just metadata operations, all of that is always stored on SSD-based flash storage. So we've done all the heavy lifting to configure the Lustre file systems so that they can be used in the most optimal way on AWS. And because we believe that customers should get access to as many of the native capabilities of the file systems we manage, you can still fine-tune on the client side a number of options for your workload if you find that you've got something unique that you'd like to do with your file system. Yesterday, we also announced the next generation of our FSx for Lustre file systems, which are now the current generation. These file systems are built on the latest Graviton processors. They provide 5 times higher levels of throughput per terabyte compared to our prior generation, 60% better price performance, and 4 times higher throughput per client instance. And this is the real value of building on the latest and greatest compute, storage, and networking that we have on AWS, as we can constantly iterate and we can provide this kind of performance boost as it's available. Here's a view of what the offering looks like for our persistent storage options. You can see some of the hard disk options and some of the all-flash SSD-based storage options. And what you see is a range of throughput levels from 12 megabytes per second per terabyte of storage, that's how it scales, all the way up to 1,000 megabytes per second for a terabyte of storage. And as you go down the rows of the table, you can also see that the price for a gigabyte per second of throughput, a file system with a gigabyte per second of throughput, running for 1 hour decreases down to 82 cents. So one of the things that I often speak to customers about is the cost, the price of FSx for Lustre. And the natural tendency of many customers when they think of a high-performance storage solution is to think, this must be really expensive. I don't know if I need this for my workload. And when we break it down to an hourly basis, which for many customers is all they might actually need, it's actually less than $1 for a gigabyte of throughput. It's a couple dollars as it starts to add up. But you can really squeeze out a lot of value by running this kind of high-performance layer for the duration of your workload. We have other capabilities as well that help to reduce the cost of running FSx for Lustre. One of the best features of Lustre is that it has a native data compression capability. So when you look at a file system and it has on each server 640 megabytes per second of network bandwidth and 250 megabytes per second of disk throughput, this is one of the new offerings that we launched yesterday. We spec our file systems pretty conservatively. We say they deliver 250 megabytes per second per terabyte of storage in this case. That represents the disk throughput. Any reads coming from a cache can go 2.5 times faster. If you turn on data compression, and in this case, as an example, get a 2-to-1 compression ratio happening on the file system, you can achieve an effective throughput of 500 megabytes per second, moving data to and from disk. And because the network bandwidth is even higher than that, that data can just stream in and out of the file system at a rate of 500 megabytes per second per terabyte, moving from disk. So for those of you with compressible data sets, it's a single API call to update your file system, turn on data compression. All the compression happens within the file system. Your EC2 instances that are mounting the file system don't consume any cycles to compress that data. It happens within the file system, no additional cost. And so anyone with compressible files should certainly take advantage of this. There's no impact to latencies. And if you can get any kind of meaningful compression out of your data, you can also get this performance boost. One of my customers, who's a large provider of mortgage financing in the United States, recently migrated a SaaS grid workload with 47 applications to AWS. They lifted and shifted their storage to Amazon FSx for Lustre. They turned on data compression. They cut down the amount of capacity they needed on the storage side by 50% using their compression. And they got this 2x performance increase on the Lustre file system performance. So this is data compression in motion. The third thing, and one of the most exciting features of FSx for Lustre, is the ability to access Amazon S3 data through a fast file interface. The reality is that many of our customers have IT administrators, or are IT administrators, that want to take advantage of all the capabilities of S3, all of the tiering, all of the multi-region redundancy. But their users work with files. Their applications work with files. And they want to make sure they're getting the best possible performance when they run their workloads. We see this in autonomous vehicle research, where customers are taking simulation data, putting it into their AWS data lake. We see it in the media and entertainment space, where customers are taking their media files, putting them in a data lake. And then what they want to do is they want to run their video rendering workloads. They want to run their software in the loop simulations on a range of compute options. And they want to do that with as little data movement and as little management as possible. So here's the way the S3 integration works. You create your FSx for Lustre file system. You link it to one or many S3 buckets. You run an API call to import metadata from your Amazon S3 bucket. And that metadata allows you to present all of those objects as files on the file system. The data hasn't actually moved. It's just the metadata. From there, you mount Amazon FSx on your compute instances, and you start to interact with the data. If you open a file and try to read data, we'll seamlessly retrieve that data from S3, load it on the file system, and allow you to open and read your data. Once the data is on FSx, it stays there. It's cached. That means no additional request costs to get that data from Amazon S3 again. It means sub-millisecond latencies for any subsequent requests as well. If you add data to S3, if you remove data from S3, that's reflected on the file system. If you write data to the file system, you can choose to use an API to export changes back to S3, to run an automatic export policy, to constantly be moving data back from your file system to S3 and to keep them synchronized, or to have no changes reflected back on S3. Keep it as read-only, and you have that flexibility. When you're done with that, if you want, you can spin down your file system. Use Amazon S3 as your single source of truth, your permanent data store, and only pay for Amazon FSx for Lustre for the duration that you need to run your workload. I have customers today that create 1,000 file systems per day with this kind of model. They run their workloads for around 30 minutes, and then they shut them down. Less than 50 cents for a gigabyte per second of throughput for their workload. I have other customers that spin up a petabyte of storage with hundreds of gigabytes per second of throughput. They run that for a few hours. When they're done with it, they shut it down. And now with the launches that we had yesterday, with some of the automatic import and export capabilities that we have, we know we have a lot of customers that are looking to create their file systems, link them to Amazon S3, and just keep them up and running as a fast file interface that fronts their S3 data and provides seamless access for all their users and their file-based applications. Another really exciting use case that we're hearing a lot about is the ability to have a single source of truth, single Amazon S3 bucket that can be used to distribute data across multiple regions or even to local zones. In this model, you have multiple file systems all reading from the same S3 bucket. Because we lazy load data, we're not actually making multiple copies of the S3 bucket. We're only moving the data that's required. We're moving it seamlessly, and we're moving it in real time. to put all of this together, I wanted to share this case study that we ran with a little bit of a benchmark using Amazon SageMaker and a liver data set from Kaggle. What we did here was we trained a machine learning model using this liver data set in a very typical workflow that we see, not just in machine learning, but in a wide variety of workloads where customers have data on S3, they want to process it, they'll move it to an EC2 instance with an EBS volume, they'll run their workload, and eventually they'll push the results back to S3. We see this in a wide range of workloads, including with ML training jobs. And so the typical workflow is as follows. You take your data on S3, you spin up your training instance, you move the data to EBS, you run your workload, in this case a training workload, and then you save the results back. And what we found was by switching from EBS in this case to Amazon FSx for Lustre, the first thing we were able to do was run our workload without any dedicated data movement. The data download time disappeared because we could start to lazy load and run our workload right away. So we weren't paying for the training instance just to move data. As soon as we had the training instance ready and the file system mounted, we could immediately access our data and start to train our model with the first epoch. By the time this was done, we had reduced the training time by 70%, and that 70% is from two sources. One is the fact that we didn't have to move the data in advance. The second is that we were able to scale up the performance of the Amazon FSx for Lustre file system to maximize throughput to our training instance, avoid any kind of bottlenecks, and through that, we were able to reduce the time of the training model by 70%. When we ran the workload again, it was even faster. So now we were able to do it 80% faster. And that's because in this case, the data was already on the file system. We see this kind of benefit in a few different use cases. In this case, training a model, hyperparameter optimization, where you're constantly tweaking the model, but the data is effectively the same. You can get that kind of extra boost. We also see this benefit when customers are using EC2 spot instances. Because as we all know, EC2 spot is a great way to run compute at very low cost, but that compute can be reclaimed. And if you've moved data from an EBS volume or to an EBS volume from S3, and then you lose that instance, it can be pretty painful to try to re-coordinate what data was moved to that particular node to start that job up again. With one single shared file system, all the data is moved to one interface. That file system can be mounted on all of your spot instances, and you can easily just replace any compute nodes and avoid having to bring that data back again. It's already hydrated, it's already ready on the file system. Now, I've talked a lot about my experiences and my customers' experiences with Amazon FSx for Lustre. I wanted to turn things over to Jeff Lee to share some of his experiences as well as Associate Director of Cloud Infrastructure at Foundation Medicine.
Hello, everyone. I'm Jeff Lee. I lead the cloud architecture team here at Foundation Medicine, and thank you, Jordan, for the introduction. So today I'm going to talk a little bit about who we are at Foundation Medicine. What do we do? How do we do it? And I'm going to go over a couple of use cases in which we employ FSx Lustre to meet some of the scaling and growing challenges that we have. So who are we? Foundation Medicine is a genomics insights company, and our aim is to improve cancer care. To do that, basically, we want to get the right information to the right people because we believe that with the right information, the right decisions can be made for patients' cancer care. So that means getting it into the hands of the patients, physicians, therapy developers, what have you. So now, how do we do this? how do we do this? Well, we do comprehensive genomics profiling. What does that mean? Well, we basically take sequence data, we crunch it through our HPC environment, and we produce tangible information that can be translated and provided to our physicians, our patients, our therapy developers. Now, of course, genomics data is notoriously large, and so it requires a lot of resources to crunch through it. So as we turn the knob of having more compute, we need to have performance storage as you slam away at a storage service in parallel across thousands of cores. So, that was the innate challenge we had when moving to the cloud. How do we do this? So for the rest of the talk, I'm going to go through a couple of the use cases, research workloads, production workloads, and how we utilize FSx to meet those scaling challenges. There we go. So our research workloads. Now, the way that our researchers work is that they kind of interrogate these genomics files, and they develop these algorithms to get the information they need from it. So oftentimes, most of the times, they're interrogating a single thread, interrogating some files, trying to get some values, something that is kind of useful information they want to put into our diagnostic services. Then once they find something of use, they funnel it through our HPC environment, meaning thousands of compute cores hitting the same storage and the same data, so they can correlate across multiple samples and see what we find now. Now, I'm going to go through our cloud journey a little bit. And so when we first started, we were on-prem, and we had NFS, and that's how we provided this data to our researchers, and that's how they work. They use POSIX file systems. Oh, that's the laser. The first thing we did when we moved into the cloud, we just did the classic, we lift and shifted it. They had NFS on-prem, they get NFS in the cloud. Doesn't change the way they work. They got to focus on the science. So to do that, we employed a self-managed storage appliance. Worked great. It gave them the NFS POSIX file system they needed, gave them the data they needed. They were off and running. It's great. Over the next couple of years, as the data grew, as the research demands and resources grew, and we had more researchers, we're starting to see some bottlenecks, some ceilings we're hitting with this self-managed storage appliance. One of the big ones was throughput. So researchers, again, it's a spiky kind of a workload they have. For the most part, they're just interrogating single files, and they put it through this parallel compute. So we're hitting bottlenecks when they spiked up. So after a couple of years, we basically started looking around for some additional options to empower our researchers. Right around this time, FSx HDD came out, and it checked a lot of the boxes for our researchers. Again, it was a POSIX file system, so it meant that they didn't have to change the way they worked. It provided the scalability of petabytes of storage for them, gave them the throughput they needed for their spikes, but also it was a cost-effective solution, which was great. And the last thing is that with the self-managed storage appliance, over a couple of years we were using it, it started having an operational overhead. And FSx HDD is a managed service for us. So while the engineers do utilize CloudWatch alarms to monitor it and notify us, it doesn't have that kind of overhead that we had with operating the self-managed storage appliance. So big win all around. So that's how we empowered the researchers. Now, we're also moved our production diagnostic services into the cloud. And so the more we did with our production diagnostic services, the more scale we needed there too. And I guess we also use the same the self-managed storage appliance in the cloud to basically house all of our pipeline code. And our pipeline code is what runs our diagnostic services. And we also started hitting the same bottlenecks with the limitations to the throughput, limitations to how many cores we could slam away at this storage service. So Around the same time, 2 years later, we looked at FSx SSD backed by S3. So through FSx SSD, we were able to meet the demands of scaling our production diagnostic services, our pipeline, vertically with the throughput needs that needed, but also we started to want to scale horizontally to more regions. We wanted to help more patients globally. And because our pipeline code is difficult to package up, to move it around to other regions, we looked in S3 Sync to kind of distribute that code globally. And it was great because once we figured out how we could run our code in HPC format vertically, and we can now do the same thing by using S3 Sync to bring that code somewhere else and run it by fronting it with FSx SSD. So it was great. It was also a cost-effective solution for us and globally available. And again, our pipeline runs POSIX, or it's a POSIX file system that we need to run our pipelines and our diagnostic services. So it also checked, FSx checked many boxes for us to be able to scale up, scale out to help more patients. So that's the way we utilize FSx here at FMI currently. So what's next? Well, as the sequencer technologies get better, that means there's more data. There's more data coming out of these sequencers. More data means more compute. More compute means, more of everything. More information's coming out. More information means more information for the researchers to interrogate. They're developing better assays, better products, which require more resources. So at the end of the day, to help more patients, we need more, which is more, which is more, which is more. So that's what's next in store for us here at Foundation Medicine, going global, using FSx to help us meet those challenges. At this point, I wanted to highlight a couple things. Throughout our journey to meet these challenges of scaling, AWS really, really listened to our feedback because, we're trying to marry science and technology. And, it's a little unique. And the FSx team, Jordan, they really came, they sat down, they listened to us, they took our feedback, they offered, possible solutions and options, but then they folded up some of those feedback and introduced it into some features. And I'm looking forward to some of the things you launched, yesterday to see how else we can utilize FSx services to improve what we're doing here at Foundation Medicine. So really, thank you very much. And the last thing I'll say is, we're growing, FMI is growing, we're building our team out. Please, if anybody is interested in what we do, you want to join our team, please come and check out our career board where we got remote positions. Looking forward to talking to anybody who's interested in joining us or interested in what we do. And thank you very much.
Perfect, thanks. So we'll open up for questions here. If anyone's got anything top of mind. So when we start up here in the front.
Hey, Jeff, thanks a lot. Can you guys comment a little bit about encryption within the encryption at rest and encryption in the various stages of Lustre FSx and how that works with compliance?
Sure, why don't I talk briefly about what
Yeah.
so the question was, can we talk a little bit about how encryption works and what's supported? So let me share what the service allows, and I can pass it over to Jeff to get his take as well. So FSx for Lustre is a storage service. All data is always encrypted at rest within the file systems. And then we rely on Nitro-based encryption, so one of the AWS technologies that's available. If you use certain instances, all data is encrypted in transit when it's moving between a client instance and the file system. And it's automatic and it has no performance impact or no adverse performance impact when kind of encrypting and decrypting that way. So those are the technologies we rely on. Every file system is encrypted at rest, and then any communication coming from a Nitro-based instance will be encrypted in transit. Jeff, you want to?
Yeah, so, sorry. So for us, It's HDD, so all the research workloads. It's encrypted at rest on the FSx HDD. But like as we were utilizing it for distributing our pipeline code, we encrypt the S3 buckets. So it's encrypted at rest there. Then the cache that fronts that S3 bucket is also encrypted at rest and in transit as well. So it, not only did it using S3 sync to provide a way to sync our source of truth of pipeline code around the world into multiple regions. It was encrypted, it was secure, it was great. And then FSx, the cache, is also encrypted. So it was multiple layers of encryption.
Just a follow-up question, that's all the way we would expect with KMS or HSMs or
Yeah, so
all the usual tricks?
yeah, KMS and CMK, yeah, supported on FSx for Lustre.
And CMK, thank you.
Yep.
Thank you.
Yep. Cool.
There's a question in the back here.
Yeah, I was wondering about using CloudFormation to set up the file system and mount it to S3 and then maybe connect it to some compute. Can you speak to that?
Jeff, do you want to take this one?
Sure. Yeah, so we do leverage infrastructure as code to basically spin up our Lustre file systems. And the mounting part, it's really a systems level thing. So you got to mount it from the OS itself. But yeah, I mean, everything else about the configuration, it's all automated, configurable. It's great. So, we can spin up these repeatable, reliable kind of like file systems around the world, again, to run our diagnostic services. So it's very repeatable.
Yeah. So, for just a quick recap of that question, so, how does this work with something like CloudFormation? So fully supported CloudFormation, support for the FSx API. The FSx API is actually quite simple. It has only a few commands. Basically, you're creating a file system, you're updating it, you're deleting it. There's a couple extras, but it's quite a simple API setup. And then we take care of the building of the file system, and then it's all mount points underneath that for the instances.
I guess a follow-up question, then how is that made available to batch? How would your batch know where to reach that file system?
So batch, typically customers will use the templates that they kind of configure for their batch jobs will point to the particular file systems. And there is another API called describe file systems where you get listings of all the file system IDs. You can filter that as well to kind of narrow down if there's particular tags you're looking for or anything of that sort.
Does local node cache the client cache also, or is it just one server?
So yeah, the question here was, what kind of caching do we see on the client side? So we are running Lustre 2.12. It's a particular version of Lustre. It's the latest long-term supported version for FSx. Every client, when you install the Lustre client, there's a kind of a thin client to install before you can mount a Lustre file system. That client does a number of things for locking purposes. It also secures 50% of the RAM on every client instance to be used as local caching. So any data that's read from the file system is kind of allocated as part of that 50% of the RAM on your client instance. That's tunable. That's one of the things that I was alluding to before. There's a lot of defaults in the way that we have Lustre set up and the client set up, but that's something you can tune if you want more or less based on the size of your instance. And that certainly accelerates kind of repeat reads on the client side. Yeah, so it's only on the memory cache. Disk cache is part of Lustre 2.13. So we'll get there when we get there. Mm-hmm.
Question about multiple availability zones. So how do want to end up getting cross availability zones? Does the Lustre support several availability zones? And can you instance from zone A access and point to zone A?
So you can mount a Lustre. So actually the question was, how do we think about Lustre and multiple availability zones? What's supported and just, what's possible? So I should start with saying that you can mount a Lustre file system on any client instance anywhere in the world as long as you are in the same security group and as long as you can get into the same VPC. So we're pretty tightly controlled on that VPC side. You have to VPN in to get that VPC access or VPC peer, but then you can mount FSx for Lustre from on-premises if you wanted to, or from just a different account. In terms of multi-AZ kind of needs, we typically see that question come up in two types of contexts. One is customers who are wondering about disaster recovery and kind of redundancy of their data. So a couple notes on that front. If you're running a standalone FSx for Lustre file system, so it's not linked to S3, all of those file systems live in a single availability zone, and we have added to our Lustre service the ability to take a backup of the file system and have that happen every day, every few hours with AWS backup, incrementally take these kind of point-in-time crash-consistent backups and have those uploaded to Amazon S3 and kind of distributed across availability zones for easy access. Any of those backups can turn back into a file system within around 5 to 10 minutes. So if you're just looking to secure your data and ensure that you can quickly recover in the case of a disaster recovery use case, that's an option. If you are looking to just get access to your data from compute instances in multiple AZs, which is probably the more common request here, one of the things that we typically see is customers having multiple file systems, one in each AZ, with the appropriate level of throughput that they need for the compute capacity in that AZ. And the reason why that's preferable is because they actually get the lowest possible latencies by keeping those disks co-located with their storage or with their compute instances. So that's the typical approach that customers take when they're trying to maximize the performance for these HPC workloads, but still get larger compute pools to work with.
So I want to follow up on that because I think the common, you spoke of the common use case where we're doing HPC clusters where we're going to take advantage of autoscalers to spread our workloads across the availability zones, get the best spot market pricing. But in Lustre for migrating from S3, you're basically saying you need completely different processes. You can't have one common process. Or we just cross region.
For sure. So that is one of the kind of current limitations of the actually, I should state that the question here was, how do we think about kind of having compute and storage across multiple AZs when we don't know where compute's going to appear with something like EC2 Spot. That is certainly kind of an unmet need in terms of how to coordinate that with something like EC2 Spot, where the compute may appear somewhere different than you expect. And so if you don't know in advance and you can't create that storage in preparation for where the compute's going to live, that can be an ongoing challenge. But typically what we find is many of our customers are able to isolate their compute to a single AZ, even with something like EC2 Spot, or create that file system after their compute has launched, and then basically get that metadata prepared and start to launch. So there's a little bit of a lag, but that's the way that typically people will run that today.
We can't mount from Lambda currently, right? We can mount EFS, but we can't mount Lustre.
Yeah, so the question is, can you mount FSx on Lambda? So today you cannot. It's something we're certainly interested in exploring. We've had some customers who have expressed interest in getting that kind of instantaneous compute of Lambda. But yeah, today it's ECS, EKS, and EC2 when you're running your compute.
Put inside ECS and EKS as well.
Yeah. So the question was, how do we think about data compression with the caching layer? So the cache is already feeding the full network bandwidth of the file system. And since the data has to be basically decompressed on the processor before it's spit out to the front-end network interface of our file servers, it basically is decompressed and compressed before it hits that RAM cache, and the RAM already gets the full benefit of the network bandwidth. So the real bottleneck that we can kind of unlock with compression is on the disk throughput. So RAM isn't subject to that anyway. So there isn't really there's no additional benefit to get from the RAM sending data out to the front-end network interface. Question in the back?
This is a long shot, but since FSx for Lustre can improve performance for file-based access to S3 objects, does it integrate with Athena?
Today it does not, but I'd be very interested. So the question was, does FSx for Lustre integrate with Athena? So it does not today, but we are exploring integrations with some of the other kind of fully managed services, especially on the analytics side. So we'd love to hear more about the use case and how you're interested in maybe using FSx for Lustre. Mm-hmm. Yeah. So is Fargate supported on FSx for Lustre? No, not today. It is another thing that we're exploring right now, and I would highly recommend anyone who's interested in actually Lambda or Fargate to kind of work with your respective account managers, solutions architects, et cetera, to provide that official feedback stream straight to the services. We absolutely listen to that kind of feedback, and we kind of have joint collaboration efforts with the Lambda team and Fargate team, et cetera. So yeah, we're always listening. Okay, maybe one question over here, and then I'll shift over there.
Yeah, so can you talk about the file access policy on FSx? If you're mounting it on top of S3, is any of the S3 carry over to FSx?
Sure. So how do we think about permissions management with FSx for Lustre, especially with S3? So there's a few different ways to lock down permissions to the file system. The first is at the AIM level, and that, just like everything else, the API you can control with AIM permissions, but that really only allows you to control the creation and deletion of the file systems. Then the next set of permissions that's more about mounting the file system is all through security groups, network ACLs, and the VPC access. The next layer after that is at the file level, which, as Jeff noted, we rely on POSIX, UIDs and GIDs to control permissions to particular files. FSx does inherit those from S3. So if you had typical POSIX storage on premises and you use something like data sync to move that data to S3, all that permissions data is stored in metadata on S3 and then can be retrieved seamlessly through FSx, and we kind of inherit and abide by that. The last thing I'll note is there's also the ability to mount portions of an FSx for Lustre file system. We call that file sets. So you can mount a portion of the file system. You can mount a portion of the file system. That is not a kind of secure way to manage your data, because anyone with root access could mount the whole file system. But if you are controlling root access on the clients, it's something you could do to just expose a portion of the file system. I think there's a question right here first.
Is it possible to have multiple master file systems connected to one S3 bucket?
Yeah, so is it possible to have multiple file systems connected to one S3 bucket? So yes, it's kind of the single source of truth option, and it's very efficient for multi-AZ or even multi-region kind of caching of data. The one thing to keep in mind there is for read-only applications, it's obviously quite effective. If you're reading and writing, just like any other kind of S3 put, there's the risk of that last writer overwriting data. So you just have to think about how you make sure that you don't have people overwriting each other in the wrong order effectively. Yeah, go ahead here.
Is it possible then to have the push afterwards?
Yeah, so can you moderate or modulate or kind of adjust how data is written back to S3? So you have two options for moving data back to S3 if you choose to move any data back. The first is using an API, and so it's complete control down at the directory level what gets written and when. And the second is using our automatic export policy. And we just track and push data back all the time. There was a question at the back there.
Performance, can you comment on latencies comparing Lustre versus, let's say, reading directly performance? If I have an option, I'm writing the code in HPC, I can go either way. Right? So do you have an article that would basically maybe provide some guidance, DFS versus Lustre versus direct
Yeah. Yeah, so we don't have any kind of published articles on something like this. What I can tell you is, small file I/O that's dominated mostly by latency is in the sub-millisecond range on FSx for Lustre. I think for Amazon S3, because it's over public internet, I believe there's actually websites you can kind of test and see what the latencies would be for a particular region to and from your compute. So that's an option to run and test something like that. I don't know the data offhand for something like EFS, but what I can say is in the family of FSx file systems like ONTAP or NetApp ONTAP or FSx for OpenZFS that we just launched, because they're single node versus FSx for Lustre, which has all of these multiple nodes and 2 round trips to go to and from a metadata server and eventually to the data server, you will see even lower latencies on some of those scale-up file systems. But both of them are in the sub-millisecond range.
So in case where you're using S3 and you do want to see data back, particularly if you're on that data back, any gotchas you can comment on if you have bucket version turned on or
Any gotchas with moving data back to S3?
particularly with bucket version.
I guess, is there a particular concern you might have on something like that, or you want?
A similar kind of concern came up with using storage gateways. We typically turn on versioning on our data buckets because it's a little bit of a repository. And that's to protect us in case anyone tries to delete accidentally or otherwise or overwrite data. But in theory, if you're writing TCP data back, then you could end up with lots of multiple versions of possibly accumulating all the code.
Yeah.
It's more likely as a nerve issue depending on the use case for storage gateway. But with FSx for Lustre, the automatic screenshot, I'm not sure.
Off the top of my head, I'd probably say I want to check on that one before I give a definitive, this is how it works. We launched it yesterday, and I don't know off the top of my head how that versioning works right now. So I'd probably have to check on that one.
Yeah, that would be an interesting question. Like, do you write back when the file's closed, as it's being written?
So how do we determine when to write back, or how does that work? So that I can speak to. So the write back today is asynchronous. So whenever the data is basically written to the file system, we will attempt to push it back to S3, as soon as possible. So if you close it and then it's sitting there, it doesn't happen instantaneously. It doesn't kind of write back before it's closed, but after it's closed, it'll try to write back.
You said asynchronously as it's being written and set up.
Sorry, after it's closed. Yeah,
Okay.
yeah.
So when it fans out to X nodes, after the file's closed, all those nodes,
If a single file is distributed amongst many servers, what we will basically do is use those same servers to push that data back to S3. And so yeah, that's the way that works. Yeah. Yeah, it is a single write. Yeah, I have to look through maybe how it creates a new version or not. Just want to be very specific on that. Question over here.
Do you have anything in the roadmap for continuous discovery of data within finance of an S3, typically for
Mhm.
having a static subset of the data in the file system at the moment, right?
Sure. So the question is, what happens if I keep adding data to my S3 bucket? So the metadata you can choose to have it continuously imported as it drops into S3. It happens instantaneously. So if you add a bunch of new objects, those will show up as files through our automatic import mechanism. And so a very popular use case, cryo-EM workloads, very common with FSx for Lustre. And yeah, we see that in healthcare life sciences. We see it in autonomous vehicle research. I get back from a drive, I load the data, I want it to appear. So that's, yeah, if you just turn on the automatic import capability.
For pricing, since you're lazy to load, let's say I've got a petabyte S3 bucket. I need to access 100 gigs of it. How much do I pay? Or how much I pay?
So the price. So the question is, how does Amazon FSx for Lustre pricing work? So it's probably most analogous to something like EBS. It's provisioned storage. With that volume, you get a certain amount of performance. And whether you use it or not, you pay for it until you tear it down. So then the question is, do I have to have the same size as my S3 bucket? So you don't. Typically, customers do not have a file system that matches the size of their S3 bucket. They try to size their FSx for Lustre file system to match their hottest working data set. You have a couple options here. One is you can work with that data set, run your workload, tear down the file system at the end. Another option is to evict data as it's no longer needed. So you have your working data set, and as you reach a certain threshold, you start to evict data that's no longer needed. We have a script that allows you to do a little bit of that through kind of a Lambda function that's available online that you can work with if you're trying to kind of keep a certain provision storage. On that topic, if you ever run out of storage on FSx for Lustre, you also have the ability to add more capacity with a click in the API or a click in the console or an update API call.
But that's not automatic, nor evicted.
Those are not automatic, correct. Yeah, create a little Lambda function for
Unless I already have we recently used logic, or is that?
the script that we have today is not least recently used. It's a very kind of basic looking for files that are not dirty, that can be easily retrieved from S3 again. But the kind of idea of a least recently used policy is something we're exploring. Mm-hmm. Question at the back?
How can I get more metadata for the given file system?
Sure.
Other than the previous side?
Yeah. So one of the things that we do today is as you add more capacity to your file system, because we're fully managed, because we're trying to keep things simple for our customers, we are always scaling metadata resources, metadata performance along with capacity because those typically go in tandem, but not always. And so another thing we're exploring is how we can provide more flexibility in metadata performance. But today we do scale it, but we do it along with the storage capacity.
Is there if I call support, will there be additional training they can do in the backend?
On metadata performance, that's not a client tune. The question is there anything we can do on the client side for metadata performance, kind of increases? So there's not any client side options to improve metadata performance. What I will say about kind of this topic in general is that there's very few workloads that we've found where metadata performance becomes kind of a bottleneck because we are already scaling some of these. There are some, and we're working with those customers to better understand their needs for future capabilities. But by default, that's not an extremely common kind of challenge we see on FSx for Lustre.
Cool.
All right. Well, thank you all so much for attending today. please, if can you just advance the slide, maybe two more here. Yeah, please complete the session survey, and we'll stick around for a few minutes, Jeff and I, if you have any additional questions. Thank you so much.